Explaining electrical issues to a client requires a delicate approach. Firstly, address the situation diplomatically by stating that an electrical issue has been discovered in the junction box that once housed the panel. Then emphasize that during the inspection, it was found that the neutral bar is still in use, which is not up to code. Secondly, stress the importance of safety. Explain that safety is the top priority and it is not possible to proceed with the new circuit installation until this issue is addressed. Elaborate by stating that combining neutrals on a single bar can create dangerous overloads and potential fire hazards. Thirdly, explain the additional work involved. Clarify that to meet code requirements, it is necessary to rewire all the neutrals in the junction box to establish single circuit neutral paths. Mention that this additional work will take additional time and effort. Fourthly, discuss the timeline impact. Acknowledge that this will impact the timeline for the new circuit installation. Provide an estimate of the additional time the rewiring will take. Fifthly, present the options. Explain that it is possible to proceed with the new circuit installation immediately, but strongly recommend addressing the neutral issue first. Alternatively, a time can be scheduled to complete the rewiring before proceeding with the new circuits. When communicating this information, avoid overly technical jargon and focus on the potential consequences of not addressing the issue. For example, explain that improperly wired neutrals can lead to flickering lights, overheating circuits, and even electrical fires. Use visual aids such as diagrams or photographs to illustrate the problem and the proposed solution. This can help the client understand the issue more clearly and appreciate the importance of the rewiring work. When discussing the timeline impact, be transparent and realistic. Provide a clear estimate of the additional time required to complete the rewiring and explain any potential delays that could arise. Offer alternative solutions, such as working overtime or bringing in additional resources to minimize the impact on the overall project schedule. When presenting the options, be sure to explain the pros and cons of each approach. Emphasize the long-term benefits of addressing the neutral issue before proceeding with the new circuit installation, such as improved safety, reliability, and energy efficiency. Reiterate that the goal is to ensure the safety and proper functioning of the electrical system. Express appreciation for their understanding and cooperation. By following these steps, the client can be effectively informed of the electrical issue and ensure that the necessary rewiring work is completed in a safe and timely manner. When rewiring the neutrals, adhere to the National Electrical Code, or NEC, and local electrical codes. These codes provide specific requirements for the installation of electrical wiring and equipment, including the size and type of conductors, the methods of wiring, and the grounding and bonding requirements. Ensure that the neutral conductors are properly sized for the circuit they serve. The size of the neutral conductor should be based on the calculated load of the circuit, taking into account any directing factors that may apply. Use appropriately sized wire connectors to connect the neutral conductors to the neutral bar. The wire connectors should be listed for use with the type and size of conductors being used. Ensure that the neutral bar is properly grounded to the electrical panel. The grounding conductor should be sized according to the NEC. Test the neutral wiring to ensure that it is properly installed and functioning correctly. Use a multimeter to measure the voltage between the neutral conductor and ground. The voltage should be close to 0 volts. Follow these steps to rewire the neutrals safely and correctly, and ensure that the electrical system is in compliance with applicable codes. To elaborate further, consider the specific requirements outlined in the NEC regarding neutral conductors and their proper installation. Article 220.61, for example, addresses the optional method for calculating feeder and service loads for dwelling units, which can impact the required size of the neutral conductor. Article 250 covers grounding and bonding requirements, which are crucial for ensuring the safety of the electrical system. Specific sections within Article 250, such as 250.24, address grounding requirements for separately derived systems, while 250.28 covers bonding requirements for services. Article 300.3 addresses the general requirements for wiring methods, including the requirement that all conductors of a circuit, including the neutral conductor, must be installed in the same raceway or cable. This helps to minimize inductive reactance and ensure proper circuit operation. Article 310 provides detailed information on conductor ampacity, including dating factors that may apply under certain conditions. When selecting wire connectors, ensure that they are listed and labeled for the specific application. UL Standard 486-486B covers wire connectors for use with copper conductors, while UL Standard 486C covers wire connectors for use with aluminum conductors. Properly torque the wire connectors to the manufacturer's specifications to ensure a secure and reliable connection. Use a calibrated torque wrench to avoid over-tightening or under-tightening the connectors. When testing the neutral wiring, use a calibrated multimeter to ensure accurate measurements. Measure the voltage between the neutral conductor and ground under various load conditions to identify any potential problems. Perform a continuity test to verify that the neutral conductor is properly connected to the neutral bar. Carefully inspect the neutral bar for any signs of corrosion or damage. Clean the neutral bar with a wire brush and apply a corrosion inhibitor to prevent future corrosion. Document all work performed, including the date, location, and description of the work. Keep a record of all measurements taken and any problems encountered. Providing this detailed information to the client can help them understand the importance of the rewiring work and appreciate the value of your services. Furthermore, it demonstrates your commitment to safety and quality, which can help build trust and strengthen your relationship with the client. By addressing the neutral issue proactively and thoroughly, you can help prevent potential problems and ensure the long-term reliability and safety of the electrical system. In addition to the technical aspects of rewiring the neutrals, it is also important to consider the customer service aspects of the project. Be polite, professional, and respectful at all times. Listen carefully to the client's concerns and answer their questions thoroughly and honestly. Keep the client informed of the progress of the work and any unexpected delays. Clean up the work area thoroughly after the work is completed. Provide the client with a written invoice that clearly outlines the work performed and the materials used. Follow up with the client after the work is completed to ensure that they are satisfied with the results. Provide a warranty for the work performed and be responsive to any warranty claims. By providing excellent customer service, the client can be made to feel valued and respected. This can help to build a positive relationship and increase the likelihood of future business. Moreover, providing good customer service can lead to positive reviews and referrals, which can help to grow the business. In the event that the existing junction box is not large enough to accommodate the additional wiring required for the rewiring work, it may be necessary to install a larger junction box. When selecting a junction box, ensure that it is listed and labeled for the intended use. The junction box should be sized according to the number and size of conductors that will be installed in it, in accordance with the NEC. The junction box should be made of a durable material that is suitable for the environment in which it will be installed. Install the junction box in a location that is accessible for future maintenance and repairs. Use appropriate wiring methods to connect the conductors to the junction box. Ensure that all connections are secure and properly insulated. Ground the junction box according to the requirements of the NEC. Label the junction box to identify the circuits that it serves. By selecting and installing the correct junction box, ensure that the wiring is safely and properly protected. Additionally, consider the specific requirements of the local electrical code when installing the junction box. Some jurisdictions may have additional requirements for the type of junction box that can be used, the location of the junction box, or the wiring methods that can be used to connect to the junction box. Consult with the local electrical inspector to ensure that the installation is in compliance with all applicable codes. In addition to the technical and customer service aspects of the project, it is also important to consider the safety aspects. Before starting any electrical work, always disconnect the power to the circuit being worked on. Use a voltage tester to verify that the power is off. Wear appropriate personal protective equipment, such as safety glasses, gloves, and a hard hat. Work in a well-lit area and avoid working in wet or damp conditions. Use only tools that are in good condition. Be aware of the potential hazards of working with electricity, such as electric shock, arc flash, and explosions. Follow all safety precautions and procedures. If unsure about any aspect of the work, consult with a qualified electrician. By following these safety precautions, the risk of accidents and injuries can be minimized. Remember that electrical work can be dangerous, and it is important to take all necessary precautions to protect oneself and others. The 2023 National Electrical Code, or NEC, includes several updates and revisions that are relevant to the rewiring of neutrals in electrical systems. Firstly, there are changes related to ground fault circuit interrupter, or GFCI, protection. The NEC has expanded the requirements for GFCI protection in dwelling units to include more locations, such as within 6 feet of sinks and laundry areas and utility sinks. If the rewiring work involves any modifications to circuits in these areas, the installation of GFCI protection will be necessary. Secondly, there are changes related to arc fault circuit interrupter, or RFSI protection. The NEC has also expanded the requirements for RFSI protection in dwelling units to include more circuits, such as those supplying lighting outlets in bedrooms and living areas. If the rewiring work involves any modifications to circuits in these areas, the installation of RFSI protection may be necessary. Thirdly, the NEC includes changes related to surge protection. The NEC now requires surge protection devices, or SPDs, to be installed in all new dwelling units. If the rewiring work involves the installation of a new electrical panel, the installation of an SPD will be necessary. Fourthly, there are changes related to energy efficiency. The NEC includes several new requirements for energy efficiency, such as those related to lighting controls and appliance efficiency. If the rewiring work involves any modifications to lighting or appliance circuits, the new energy efficiency requirements may need to be addressed. Fifthly, the NEC includes changes related to electric vehicle charging. The NEC includes new requirements for the installation of electric vehicle charging equipment. If the client is considering installing an electric vehicle charger, the electrical system will need to be upgraded to meet the new requirements. It's also important to consider the concept of selective coordination when dealing with electrical overcurrent protection. Selective coordination ensures that only the overcurrent device closest to the fault opens, minimizing the impact on the rest of the electrical system. This is especially important in critical systems like hospitals or data centers, but it's good practice in residential settings as well. The NEC provides guidance on selective coordination in Article 240.12. The goal is to avoid nuisance tripping of upstream breakers, which can disrupt power to essential circuits. To achieve selective coordination, consider the time current characteristics of the overcurrent devices in the system. Choose breakers with different time delay characteristics so that the downstream breaker trips before the upstream breaker. Conduct a coordination study to verify that the overcurrent devices are properly coordinated. A coordination study involves analyzing the fault currents and the time current characteristics of the breakers to ensure that they will operate as intended. Document the coordination study and keep it on file for future reference. Regular maintenance and testing of the electrical system are also important. Inspect the electrical panel and wiring regularly for any signs of damage or deterioration. Test the GFCI and RFSI breakers to ensure that they are functioning properly. Have the electrical system inspected by a qualified electrician every few years. By following these maintenance and testing procedures, potential problems can be identified and corrected before they cause a safety hazard. Keep in mind that electrical codes and standards are constantly evolving. Stay up to date on the latest changes to the NEC and local electrical codes. Attend continuing education courses and workshops to learn about new technologies and best practices. Subscribe to industry publications and online resources to stay informed about the latest developments in the electrical field. By staying current with the latest codes and standards, the client can ensure that their electrical system is safe, reliable, and compliant. In addition to the specific NEC requirements mentioned above, there are also general safety practices that should be followed when working with electricity. Firstly, Always work with a partner or have someone nearby who can assist in case of an emergency. Secondly, use insulated tools and equipment to prevent electrical shock. Thirdly, avoid wearing jewelry or other metal objects that could conduct electricity. Fourthly, never work on electrical equipment while standing in water or on a wet surface. Fifthly, be aware of the location of overhead power lines and avoid contact with them. Sixthly, never overload electrical circuits or extension cords. Seventhly, use caution when working with ladders or other elevated platforms near electrical equipment. Eighthly, be aware of the potential for arc flash and take precautions to protect oneself from it. Ninthly, use a lockout-tagout procedure to prevent accidental energization of electrical equipment. Tenthly, if unsure about any aspect of the work, consult with a qualified electrician.